Welcome back, Pre-Calc. Hope y'all are well. Our objective today is going to be to look at combinations and permutations. I've got the checklist on the screen. You know what to do from here. All right, I've got a warm-up on the screen. Go ahead and read it to yourself, and I will force pause on the screen. Go ahead and hit continue when you are ready to check your answer. All right, so there are basically 7 events. For the first event, there's 16 possibilities, and then for the second event, there would only be 15 possibilities, and so on and so forth. So 16 times 15 times 14 all the way to 10 gives you 57,657,600 possibilities. So though we used the counting principle for that example, that's actually what's called a permutation. So a permutation is the number of permutations when order matters. So of n things taken r at a time is n factorial all over n minus r factorial. So in our case, we had n was 16 and r was 7. So we had 16 minus 7 and a factorial on both of those. Okay, so the numerator here would be 16 factorial. The denominator is going to be 9 factorial, right? So think about it this way. 16 factorial is 16 times 15 times 14 times 13 times 12 times 11 times 10, I'm running out of room, times 9 times 8 times 7 ... But those last terms, notice that I can just write as 9 factorial, right? Why would I do that? Well, now the 9 factorial in the numerator and denominator divide out, and I have what we had in the previous slide, right? 16 times 15 times 14 all the way to 10. So what I'd like for you to do is write this definition as well as the word permutation. I'm going to force a pause on the screen. Go ahead and hit continue once you've got that definition written. All right, let's try computing some permutations by hand before we look at some more word problems. Can you write this in your notes, 6p2? So following my formula, we can write it like this, p 6, 2, or you can write it like so, 6p2, and this means that we are going to have a 6 factorial in the numerator over 6 minus 2 factorial in the denominator. So this becomes 6 factorial over 4 factorial. Now if we're doing this by hand, what you're going to do is expand the numerator until you get to the denominator. In other words, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, but I'm just going to go 6 times 5 times 4 factorial to take care of the rest, because I've got a 4 factorial here as well. And so now these cancel, and I'm left with just 6 times 5, which is 30. All right? Let's try this next one. Write 4p2. So this will be 4 factorial over 4 minus 2 factorial. So the numerator is 4 factorial, the denominator is 2 factorial. So I'm going to expand the numerator until I get to the denominator. So 4 times 3 times 2 factorial all over 2 factorial. Now these terms cancel, so all that's left is 4 times 3, which is 12. Let me show you how to do this on the 84 and Desmos. So on the 84, if I want to do 4p2, you're going to go to Math, it's right under the green button, scroll over to Probability, P-R-O-B, and hit number 2 where it says NPR. And we're going to go 4p2, and there's our 12 that we got. On Desmos, there's a couple ways to do it, but I would recommend just going to the keyboard for now and going to your functions. Make sure you're on Stats, and your permutation is right here. Again, NPR, and you're going to go 4, 2 here, and there's your 12. You can also just type the letters N, lowercase n, capital P, lowercase r, and it turns it into the permutation for you. All right, let's read example 1 together. It says 10 students apply for 3 scholarships amounting to $1,000, $2,000, and $6,000 each. How many different ways can the scholarship committee select the winners? So, would you say order matters here? Order does matter because it matters whether I get the $1,000, $2,000, or $6,000 scholarship, right? So this is going to be 10 P3, and we can just come to the calculator and type that in. So I'm going to go NPR 10, 3, 720 different ways. Okie doke, I'm going to force a pause on the screen, see if you can do example 2 on your own. Hit continue when you're ready to check. All right, we should have gotten 8P3, which is 336. All right, so we talked about permutations. Let's talk about something called combinations now. So this is when the order does not matter. So let's read here. It says, when we count permutations of n objects taken r at a time, we consider different orderings of the same r selected objects as being different permutations. But in many applications, we are interested only in the ways to select the r objects, regardless of the order in which we arrange them. These unordered selections are called combinations, okay? So here's the difference between a permutation and a combination. Let's go back to example 2 here. Let's say there are 8 people in the 200-meter race, and let's just say there are 3 medals, and we don't care if it's bronze, silver, or gold. We're just going to give three medals in total, okay? So what would happen is, how many different ways can I arrange 3 medals? 6 different ways, 3 factorial, right? So in other words, this is 6 times too many. So what I would need to do is take my 336 and divide by 6. In other words, divide by 3 factorial. Okay, so a permutation or a combination is very similar to a permutation. You're going to see a very similar part of it, but I need to then divide out the factorial, basically, of this number here, okay? Let me give you the formal definition of a combination. It is right here. Will you write this in your notes, please? So a combination, the number of combinations where order does not matter of n things taken r at a time. Notice that it's similar. Like, I still have this n factorial in the numerator. I still have this n minus r factorial in the denominator. But then I also need an r factorial in the denominator. Okay? So which would you say is larger? A permutation of nr or a combination? Yes, a permutation, because a combination where order does not matter, I need to divide out all those basically times that we had, that repetition. Okay, let's try some examples. So if I want to find a combination by hand, this 6 choose 2, then according to our formula, it starts the same way as a permutation, right? I have 6 factorial in the numerator. I would have 6 minus 2 factorial in the denominator. And then additionally, I'm going to have a 2 factorial also in the denominator. Okay, so let's do this. We've got 6 times 5 times 4 factorial. 6 minus 2 is 4, so this part becomes 4 factorial. And then I also have the 2 factorial, and 2 factorial is just 2 times 1, which is 2. Okay, so let's reduce a bit. 4 factorial divided by 4 factorial is 1. And then I can also say that 2 goes into 6 3 times. So my final answer is 3 times 5, which is 15. And force pause on the screen. Can you try 4 choose 2? Hit continue when you're ready to check. So we should have gotten 6 for 4 choose 2 on the 84. Again, you're going to go to math, scroll over to probability, P-R-O-B. It is number 3 NCR, and we're going to go 4C2, and there is our 6. On Desmos, again, you can grab your keyboard, go to Functions, under Stat. It is NCR. Whoops. Okay, we are having issues here. And I'd go 4, 2, and there's my 6. All right, so before we do some word problems, will you just decide for A, B, and C, is it a combination or permutation? Read through them. I'm going to force pause on the screen, hit continue when you think you've got your correct answers chosen. All right, so for part A, a president, vice president, and secretary are chosen for a 25-member garden club. This is going to be a permutation because order matters, right? It matters whether you're a president, vice president, or secretary. But for B, a cook chooses 5 potatoes from a bag of 12 to make a potato salad. That's a combination because it doesn't matter what order I pick those 5 potatoes. But C is another permutation because typically you care where you sit in a seating chart. So order would matter for part C. All right, let's read example 3 here. In the Miss America pageant, 51 contestants must be narrowed down to 10 finalists who will compete on national television. In how many possible ways can the 10 finalists be selected? So does order matter here, or order does not matter? Order does not matter. So would this be a permutation or a combination? This would be a combination. So order does not matter. So this is going to be 51 choose 10. Let's type that into the calculator. So if you type this into Desmos, you're going to get 1.2 blah, blah, blah times 10 to the 10th. So you need to move that decimal. Remember, move that decimal 10 places to the right. Okay, so here's what you get if you moved all that. So you need to add a 0, and you're going to get 12,777,711,870 different ways to select the 10 finalists. Okay? All right, I'm going to force pause on the screen. Go ahead and read example 4, and try it. Hit continue when you're ready to check your answer. So since order does not matter here, we'd have 46 choose 6, a combination as opposed to a permutation, and you'd get 9,366,819 different ways. All right, I'm force pause on screen and try this challenge question. Read it and hit continue when you think you've got it. It's a pretty tricky one. This is a combination because order does not matter. So it's actually 50 choose 11. So here's why. If I've got this deck of cards, right, and I take out the king and the ace of spades, how many cards are left to choose from? 50, right? And if I want to make a 13-card hand, I need to choose how many out of this? I need to choose 11. So if I want a 13-card hand and I want it to have to include these two, then I need to pick 11 out of these, where again, order doesn't matter. All right, so I will leave you kind of with that challenge, and I will see you all next time.